One competition, four unique perspectives, countless unpredictable moments, the roar of motors, the pulse of data, warning signals, shouts from the pit, victories and failures colliding again and again. This is more than a team of four core members. Behind the scenes, many others give tirelessly. The programmer debugging deep into the night, the mechanical hand wiping down chains, the scout logging data from every match. Their work may go unseen, but it is no less essential. In this documentary, we witness a clash of youth and ingenuity, a battle between conviction and technology.
My name is Mufeng Shen, and I'm a Academy of Math and Science student at Fort Hays State University. I'm currently a senior. I'm 19 years old.
My name is Celine Welch, and I am a junior of the CAMS program at Fort Hays State University this year. I am a part of the Tiger 9551 team, and I will be the captain next year in the 2025-2026 school year. The team was created in the 2023-2024 school year and in Hays, Kansas. Our team is composed of high school students from the community and is entirely student-led. We are supported by the Kansas Academy of Mathematics and Science and local educational institutions, including Thomas More Prep Marion High School. It is based in the STEM Harvest building provided to us by one of our sponsors, Treetop Security. We are aided by Dr. Adams in the Applied Technology Department at FHSU and in cutting and creating the materials for the parts in our robot.
At Fort Hays State University, someone first brought this challenge to campus. He is the team leader, a strategist, a decision maker, and a guide. Meanwhile, a new force is rising, stepping into leadership, taking over the torch, organizing, communicating, and leading. This is not just a transition, it is a legacy.
I know FIRST Robotics program since 2018, which when I was 14 years old. So I joined the Kansas Academy of Math and Science at Fort Hays University during junior years. And the reason I bring this program in is because FIRST Robotics competition is a very fun STEM education program that can inspire people doing engineering. And also it's a very good program for robotics design, which I'm interested in.
Their stories are just beginning. One holds the wheel with experience, the other finds his rhythm in the unknown. Now let's explore how they stepped into the team and stood side by side.
Our team has quite a few sub-teams, and we structure them by hierarchies. So we have our captain who organizes the team entirely.
I facilitated communication between sub-teams, mechanical, programming, and strategy, to diagnose problems and implement fix efficiently.
We have our sub-team captains that will organize the participants who are working in those sub-teams. Some of our sub-teams include the building team, which can either build the field or the robot itself, the CAD team, which designs the robot in a CAD program, and we also have a media team, which controls the marketing and grant application and outreach to kids and businesses. We also have the scouting team, which is very important. Most, if not all, students on the team take part in it whenever we go into competitions. We also have the programming teams who program the robot, and is led by Stanley.
My name is Stanley, and I am in charge of the programmer in our team. And I'm 17 years old, and I am in the AMS program in Fort Hays State University.
With roles defined, the real tests begin. From components to code, sketches to field trials, this is more than a skills test, it's a test of teamwork.
So we use Discord to communicate all of our messages to the team members, and mostly when we speak directly to the team, to the participants, our sub-team captains will meet with the captain, we'll organize what's going to happen, and then we'll tell the participants what they will be doing and how they will be working with others on the other teams.
And then we promptly convey it to everybody who needs to know by using communication channels. We know exactly who's in charge of what and who needs to know when something happens.
Each year, students from around the world gather to compete, not just in speed and skill, but in innovation and collaboration. Welcome to FRC, a launching pad for young engineers. Here, the real challenge isn't just the match, but the journey of growth behind it.
So when the Alliance captains made the team, they already had an idea of what each robot they chose was capable of and what their role would be in a team. So mostly going along with those roles, and depending on what the enemy robots are doing and what our robots are capable of, changing roles if necessary. One example is we learned that our autos were going to clash, so we had to make a last-second auto to ensure that we could try and score points through auto.
So since we just swapped into CDRE structure this season, and we used to use a lot of RAV components and electronics in our robots, so we're not really familiar with CDRE stuff. We do have a lot of problems, like we don't know how to really construct those motors at the beginning, and we don't know how to actually do their PIDs. What we do is we look up online, we look up in Chef Delphi, which is like a Reddit for FRC, and we will post our own thread onto that, so we can ask other teams for helps. And we also just contact with some teams that we are in front with to look up for some helps. And we also just look into CDRs themselves documentations and see if we can find a solution on our own. We do have a lot of problems that having during the programming and the building phase, and we have most of them down and solved. But during testing, there's one problem with our PID, which we're using the relative encoder that's in our motor to trace our elevator's height. And for the relative encoder, it's not very consistent, and it's just a little bit arrow on it every single time we run up and run down. And sometimes with this arrow, our wrist cannot automatically set itself to offset when the elevator is already down to the floor level, the offset level. So what we do is, although we have all the elevator and the wrist parts pretty automatic, but we still have the choice to manually control their position. We have just two buttons on our controller, which just manually resets the wrist and the elevator, so we don't bother by the arrow. We're using Java as our programming language, and we are using WPI lib that's provided by First Official to do the programs. And what we introduced new to this season is we're using the status machine for the whole structure of our robot. We used to use command-based, which for all the subsystems, we have different commands that operates those subsystems, and we have sequential or parallel command groups that drives those commands parallel or sequential. But what the problem with that is you can't really have two systems that work together. Like we need the elevator and the wrist working together this season, so we can have a automatic. By using status machine, we just separates all the status of the elevator and the robots into different status. And if we run into a different status, it's gonna automatically drive all the subsystems together. That makes our maintenance and also the process of making the robot automatic a lot easier.
Within 6 weeks, every bolt, every line of code could decide victory or defeat. A robot is more than metal and wires. It's a fusion of teamwork and creativity. From coding to mechanics to electronics, every member breathes life into the machine. The machine powers up. The match begins. In this pressure, reaction time, strategic decision-making, and synchronization can shift the entire outcome.
So my name is Alexander Redinger. I'm a student at FHSU. I am the vice president of the robotics team this year. I was part of the robotics team last year, and during competition, I played a role as the coach and the strategy team head. So in competition, there were quite a few events that we were planned for, especially parts breaking, our team breaking down, just events happening during the competition that can't be anticipated.
For example, during one of our semi-final matches, a rope on our robot's elevator was stuck with the intake, which is mainly one of our mechanical group students' problem. They didn't check it before matches. So what we basically do is we talk to them to tell them there's an issue and then let them fix it and make sure this kind of things never happens again.
We had a few plans for that. We brought many spare parts just in case. We had plans such as if our robot elevator broke down, we would start playing defense for the rest of that match and then we'd fix it afterward. A lot of it has to do with just on-site evaluation of what the problem is and how we're going to solve it, because every problem is different. Luckily, not too many problems arose, and we didn't have to put in place many of our contingency plans.
When the referee's whistle blows, every button press becomes a decision, every repair a matter of honor. Team synergy doesn't come from luck. It's forged through crisis drills and mutual trust.
Robot competitions go on for a total of 3 days. The first day, we have our practice matches, where our participants will all be scouting the teams that are playing, so we know who is doing what and how well they're doing it. And the second day will be qualification matches, which are how we determine the rankings of the teams.
So throughout the day, our teammates who weren't in the pit, which is like working on the robot, were in the stands answering a Google Sheet for each match. And in that Google Sheet, they were basically detailing what each bot in the match did. And this allowed us, especially at the end of the day when we met in the hotel, to have all this data organized for use. So everybody was able to see exactly how each robot performed, how we performed in comparison to each robot. And everybody was able to get involved through that. And we had scouting meetings every night, talking with all the scout team about how the day went and making sure everybody knew what was going on. So to remain calm during a rapidly changing competition, one of the methods that I used was I made a Google spreadsheet that shows us all the information.
2 to 3 based on the other one.
Okay, 2 to 3.
Because it also says they have a bad driver, so it's not really something you should fix.
That we possibly could need, so that we're always informed of the situation. That way we can adjust the strategy as needed whenever events arise, especially if like our ally bot breaks down, we know exactly the points that are going to be scored in the next game. We can adjust what we need to do based on that. We just remaining calm by knowing what's going to happen.
So before our first regional competition, we have very short time for our programming to be done. So what we decided is we have to make sure that every single basic or all the basic subsystem of the robot needs to be working fine. What we decide is we actually just do not work in our autonomous program anymore. We just make sure to calibrate our subsystems and all those constants to be working as ideal as we want to.
As the driver, I contact with my coaches, which is right besides me, and they will make decision.
Yeah, go to the right. You're good. I can see better.
So I basically listen to my coaches, and my coaches usually discuss with our team to make further instruction on what should we do.
So as coach going into playoffs, one of my jobs is to make sure that we're communicating with our allied teams so that we can effectively play in the playoffs. So before every match and after every match, I was meeting with the other teams, coaches and drive teams, and we were discussing what we need to do next match and what we did that match. Then after every match, we would debrief over the match, like with each other, and make sure to see what we could do next match better. So of course on the field, there's going to be unexpected difficulties, and there isn't really time to think of what is necessary and all the possible outcomes. So my role in that is making a decision on the fly of how our robot is going to react, what we're going to do moving forward for the rest of the match. Whether that's now we need to start taking algae to the processor, or we need to go play defense, which I would have known all this information beforehand based on our Google Sheets and knowing how the enemy is going to score to compare how we're going to score.
So guys, yeah, focus on the FBI, all right? Just get, where?
When they're shooting.
Yeah. Oh, right there. But don't like crash them so hard, in case of penalty, Great.
So then my role is to make that split-second decision of what we're going to do and communicate that to our team members who are solely focused on their robot so that they know what's going on and ensuring everybody is working well together.
FRC is more than just a competition. It's an education, a conversation, a test of leadership. Every explanation, every helping hand from veterans to newcomers is a passing flame, igniting passion and responsibility.
So during the competition, everybody had a role. Everybody was focused completely on that role. So an elimination or a malfunction happened, we were all just thinking of what we could do to continue our work and continue improving. After the elimination, the emphasis, like especially someone was telling us, stay positive, look at how far we've come. We're only a second-year team, and look how good we did. And if we look at the data, we can see how good we did in comparison to other robots who are much more experienced. And that just kept us optimistic and kept us going. So, I mean, as with most team events, there were certain people who didn't do their job, but a lot of people stepped up and did their job correctly. And whenever we asked people what their opinion was, everybody gave like good opinions on each bot and what they thought of that bot, and like telling us everything that we needed to know with our questions.
Failure is never the end. It tells us where to go next. Those late night work sessions, those endless rounds of testing and tweaking, that's what makes this journey unforgettable.
So basically very disappointed, but still I was proud of our team's efforts and growth. I emphasized the importance of learning from setbacks and maintaining a positive outlook for future competitions. We recognize the importance of alliance synergy and adaptability. Moving forward, we'll focus on modular robots design and flexible strategy to better respond to dynamic matches situations.
So during the competition, it was pretty easy to stay motivated because we had worked so hard for weeks on this robot. We needed to do well. So the whole idea was just striving to maintain our ranking and get to the best alliance we could be in the best spot we could be, so we would have the highest chance of going to Houston.
The match ends, but its meaning keeps spreading. Their steps won't stop. A new goal quietly appears ahead.
I will be the captain in the next school year, and we have already decided on who the sub-team captains are going to be because of all the seniors who are leaving. Because the turnover rate is so high, we have to make sure all the juniors know what they're doing and train them within 1 year. So next year, half of the juniors right now are labeled as sub-team captains, and the others are big participants who will be helping the other juniors out who join the team next year.
Yeah, so I believe next year I'll probably be a mentor for the team, and I'm very confident we can get to the playoffs. We can do a lot better than we did this year. And this year, I think we could have done a lot better too, but we had some bad luck with matchups and with alliance selection. So next year I'm very confident that we can do very well.
Today's competitors may become tomorrow's mentors, and the spirit of FRC, that of perseverance, learning, and teamwork, will live on through every new generation of engineers.